In section 7.6, we're going to work on solving equations that have fractions in them. Now, the first step is going to be to factor the bottom parts. The second step is going to be getting rid of the fractions by multiplying all the terms by a common denominator. Third, solve what's left. And then the thing that's a little bit different about this one and some of our other equations, when you're solving rational equations, you often end up with false answers. Answers that would make the bottom of one of the original fractions turn into 0 if there's a variable there. And you can't have 0 on the bottom of the fraction. So you'll see what I mean by that here in a few minutes when we get to some other examples. But let's take a look at how this process works with our first problem. X over 4 plus 4 over 5 equals 1 over 20. Now, 20, if you factor it, is 4 times 5. So let's rewrite this equation as x over 4 plus, and then let's leave some space, 4 over 5 equals 1 over 4 times 5. Now, having factored it, a common denominator would have to include all the factors. In this case, the denominators that we've got are 4, 5, and 4 times 5. So we're going to be able to get rid of some of those things by multiplying by 4 and the rest of them by multiplying by 5. So we're going to multiply every term by 4 times 5. I strongly encourage you to write out this step. Some students try to do this in their head and they end up making a lot of small mistakes. Write out this step of multiplying the common denominator one at a time by each term. What you do next, on the first one, the 4 you're multiplying by and the 4 you're dividing by cancel out. And 5 times x would be 5x. For the next part, the 5 you're multiplying by and the 5 you're dividing by cancel out, and you have 4 times 4, which is 16. It's always whatever's on the bottom of the fraction that cancels out. So the 4 on the bottom and the 4 you're multiplying by cancel out. The 5 on the bottom and the 5 you're multiplying by cancel out, and we have 1. That's the point of multiplying by a common denominator. It gets rid of the fractions. And for most people, this new equation is much easier to understand and solve than the one with all the fractions that we started with. Now you would subtract 16 from both sides, and we have 5x equals negative 15. And then to finish, you divide both sides by 5, and we have x equals negative 3. And that's our answer. So that's the process. We're going to factor the bottom parts, multiply by a common denominator to get rid of the fractions, and then solve the equation that's left. Let's take a look at our next problem. Here we have x plus 2 over 3 minus x minus 1 over 5 equals 1 over 15. So here the number 15, if we factor it, is 3 times 5. So looking at this, we can see that our common denominator is going to be 3 times 5. So we multiply 3 times 5 times our first fraction, x plus 2 over 3, minus 3 times 5 times x minus 1 over 5 equals 3 times 5 times 1 over 3 times 5. Like that. We just put that common denominator one at a time in front of every term. So the next step is canceling stuff out. On the first part of the problem, the 3 and the 3 cancel out. Here we have 5 times x plus 2. We have to distribute. 5 times x is 5x. 5 times 2 is a positive 10. Next, the 5 and the 5 cancel out. Now here's a spot where a lot of people make mistakes. Notice there's a minus in front. So you're not distributing 3, you're distributing negative 3 to that parentheses. Negative 3 times x is minus 3x. Negative 3 times minus 1 is a plus 3. Then on the right side, the 3 and 3 cancel out, the 5 and the 5 cancel out, and we're left with 1. So now, when we combine the like terms, 5x minus 3x is 2x, 10 plus 3 is plus 13, and we still have equals 1. Next, we subtract 13 from both sides, and we would have 2x equals negative 12. And last, divide both sides by 2, and we get x equals negative 6, like that. Let's take a look at our next example. Here we've got just one fraction, and it has an x on the bottom. So there's no factoring to do on this one, but we still do that second step, getting rid of the fractions by multiplying by a common denominator. In this case, our common denominator is the only denominator, x. So we have x times our first term, which is 2, plus x times our next term, which is 6 over x, equals x times x plus x times 7. Notice that you multiply the common denominator by every term when you're getting rid of the fractions. Whether the term is a fraction or not, to keep the equation balanced, you have to multiply the same thing by every term. So in this case, on that first term, we have x times 2, which is 2x. The next term, the x you're multiplying by and the x you're dividing by cancel out, and we have just plus 6. On the right side, x times x is x squared, and then x times 7 is 7x. So this takes us to a kind of equation we had in the previous unit. We want to get everything on one side so that we can factor it. And it's easier to move things to the side where the x squared is positive. So I'm going to move everything to the right side here by subtracting 2x from both sides and subtracting 6 from both sides, which leaves us with 0 equals x squared plus 5x minus 6. So now be careful with the negative signs here when you're factoring. We need to figure out what you can multiply to be a negative 6 that would add up to a positive 5. And a lot of times I see people on this problem say, oh, it's 2 and 3, because 2 and 3 add up to 5. The problem is 2 and 3 add up to 5, but they multiply to be a positive 6. We want them to multiply to be a negative 6. So that would be a positive 6 and a negative 1 would work. Now they multiply to be negative 6, but add up to a positive 5. And as we've learned from before, after you get it 0 on one side and factor, to finish the problem, you would set those factors equal to 0. So we have x plus 6 equals 0, and x minus 1 equals 0. The first one, you subtract 6 from both sides, and we have x equals negative 6. The next one, you add 1 to both sides, and you have x equals 1. So this problem, we end up with two solutions for the equation.